In the previous video, we discussed various properties of matrices and operations with matrices, including addition, subtraction, and scalar multiplication. Now in this video, we're actually going to take a look at matrix multiplication, where we multiply one matrix by another matrix. So here we will look at multiplying matrix A by matrix B. And when we consider multiplying matrices, the dimensions of the matrices that we try to multiply end up being very important. So here we have that the dimension of matrix A is 3 by 2, and the dimension of matrix B is 2 by 3. So we actually are able to do the matrix multiplication A times B and get a matrix product. And the relevant factor when we multiply matrix A by matrix B is that the number of columns in the first matrix need to match up with the number of rows in the second matrix. What this means is that in some cases, not this case, I might be able to perform matrix multiplication A times B and get a result, but it might not even be possible to multiply matrix B by matrix A. So again, in this case, the multiplication works because the number of columns in matrix A matches the number of rows in matrix B. And when we see how we do matrix multiplication, it should become clear why this is a necessary condition. And I will go ahead and name this matrix product A times B. I'm going to call that C. And so we'll have that C right here. And we're going to look at the values that we could have for the entries in matrix C one at a time. We'll start by looking at entry C11. Now C11 we will calculate by taking values from the first row of matrix A, the first matrix in our multiplication, and multiplying those by column 1 in our second matrix, matrix B. And I've just darkened up that ink color a little bit so we can see a little bit better. So what we're going to multiply here, we will have negative 5 times negative 4 plus 4 times negative 2. So we looked at this times this, plus this times this. And our result, that's going to be 20 plus negative 8 is 12. And for C12, we'll again take the first row in matrix A, and this time by the second column in matrix B. So we will get negative 5 times 10 plus 4 times 2. That's negative 50 plus 8 is negative 42. Now to calculate C13, we'll take the first row in matrix A times the third column in matrix B. So I'll get that C13 is equal to negative 5 times 5 plus 4 times 1. Negative 25 plus 4 is negative 21. And I'll carry through a little bit more quickly now for C21. We'll take the second row now of matrix A times the first row of matrix B. We will get 0 times negative 4 plus 3 times 2 is 6. C22, we will get 0 times 10 plus 3 times 2 is again 6. C23, we will get 0 times 5 plus 3 times 1 is 3. And I'll go ahead and erase a few of the previous calculations. And we'll go ahead and finish up. C31 will be 2 times negative 4 plus negative 1 times negative 2. It's negative 8 plus 2 is negative 6. C32 we will have 2 times 10 plus negative 1 times 2. It's going to be 18. And finally, C33 will be 2 times 5 plus Negative 1 times 1 is going to be 9. So we'll take a look at one more example of matrix multiplication, and we'll also see why it's so important that the dimensions match up the way they do. And I should add, I'm just becoming aware that there is an error that entry C21 should actually be negative 6. So that was just a little arithmetic error. So I've got two matrices here, matrix A and matrix B. And we'll note the dimensions first, that the dimension of A is 2 by 2, and the dimension of matrix B is 3 by 2. And of note here, the number of columns in matrix A no longer matches the number of rows in matrix B. This does mean that we cannot, in fact, perform the multiplication A times B. And we'll see why if we call that C. So, okay, C equals some matrix here. And to calculate C11, we will take the first row in matrix A, multiply that by the first column in matrix B, and we'll get for this C2 times negative 4 plus 5 times 1 plus, there's nothing to put here to multiply by that last 1 in matrix B. So that's why we have no answer for this matrix product matrix C. Now, all the time that we've done multiplication up until now, a number A times another number B has been the same as number B times number A. In matrix multiplication, that's no longer the case. I actually can perform the matrix multiplication B times A. Let's take a look. If I look at the dimensions of matrix B first, the dimensions of B are 3 by 2, and the dimensions of matrix A are 2 by 2. And so we note that now the number of columns in the first matrix matches the number of rows in the second matrix. So I'll say C is equal to B times A. Well, that doesn't really look like a B at all, does it? B times A. And so we'll say C equals here, and we'll take a look at what we get. So to calculate C11 now, we're going to multiply the first row in matrix B, which is our first matrix in our multiplication, times the first column in matrix A, which again is the second matrix now in our multiplication, and we will get negative 4 times 2 plus negative 1 times negative 3. And that's going to give us negative 8 plus 3 is going to be negative 5. And we'll go through the rest of this multiplication pretty quickly. For C12, we'll again have first row now times second column. We'll get negative 4 times 5 plus negative 1 times 1. And that's going to give us negative 21. And moving right along, C21, we'll be doing this times this. We'll have 1 times 2 plus 0 times negative 3 is 2. C22, we'll have this times this. We'll get 1 times 5 plus 0 times 1, which is 5. And C31, here times here, we will get 1 times 2 plus 2 times negative 3. That's going to be negative 4. And C32, we will have 1 times 5 plus 2 times 1, which is 7. Now, of note, the dimensions of C are 3 times 2. Look at this. 3 matches 3, and 2 matches 2. So it's kind of like these two numbers up here, columns from the first matrix and rows of the second matrix, have sort of disappeared and we're left with number of rows from the first matrix, or the number of rows in our resultant matrix, and number of columns in our second matrix, or the number of columns in our resultant matrix. So here I will look at matrices A and B are both square 2 by 2 matrices. And when I say a square matrix, I mean a matrix with the same number of rows as columns. And the reason I picked these two square 2 by 2 matrices is because I can calculate C equals A times B, and I can also calculate D equals B times A, and we will look at the results of that. So we will have C, it is going to be a 2 by 2 matrix, and I will have C11 will be 5 times -1 plus 4 times 3, that's -5 plus 12 is 7. Of C12, we will have 5 times -4 plus 4 times 7, -20 plus 28 is 8. C21, we will have 0 times -1 plus 2 times 3 is 6. And C22, we will have 0 times -4 plus 2 times 7 is 14. And then we can calculate D. Oops, D, not B. And again, D will be 2 by 2. So we'll have D11 will be -1 times 5 plus -4 times 0 is going to be -5. And D12 we will have -1 times 4 plus -4 times 2, that would be -4 plus -8 will be -12. D21 we will have 3 times 5 plus 7 times 0 will be 15. And D22 we will have 3 times 4 plus 7 times 2, so that's 12 plus 14 is 26. So as you can see, A times B gives a very different result from B times A. One final thing I can consider, when I do have a square matrix, such as matrix A here, I could ask, for example, what is matrix A squared? Well, this means, raising A to the second power means the same thing that it did when we just dealt with numbers. Now, I can virtually guarantee that if I put this on a test, some of you are going to tell me that A squared is going to be 4, 0, 1, 16. You just square all the entries in the matrix. Don't do that. It doesn't work that way. A squared is A times A, which is 2, 0, 1, -4 times 2, 0, 1, -4. Oops. And we can do that calculation pretty easily. 2 times 2 is 4, plus 0 times 1 is still 4. So I did here times here. Now I can do 2 times 0 plus 0 times -4 is 0. And I can do 1 times 2 plus -4 times 1 is going to be -2. And finally, we will have 1 times 0 plus -4 times -4 is 16. And here we have the matrix A squared. So it turns out it's actually pretty close to this product right here that was very incorrect, but this is the solution we should be getting. And similarly, I could calculate A cubed by multiplying A by A by A, or A to the fourth, A by A by A by A, or really any power of A I wanted to and had the time to work with. So for class tomorrow, I'll ask you to calculate 4 matrix products, all using the matrices here. So I'll ask you to calculate A times B, b times a. Now one of those two matrix products might not be possible, and I will also ask you to calculate b times I and I times b. And it turns out this matrix I here is a very special matrix in terms of matrix multiplication, and once you've completed problems 3 and 4 you should see why. I will see you tomorrow.